I know, right?
Going. All right. What questions do we have on page 51? Take a look at page 51. What questions do you see? This also includes those of you who chose not to do it. You are also labeled to ask. Yeah. Two. Talk to me. The no-namer?
Yeah.
Cool. Just hand it back in. With make sure your name's on it when you hand it today. Thanks, man. G at x is equal to negative 10x. And then we know that g at x is also equal to 15. So is g at x the same here and here? You mean the same thing?
No.
G at x, does it mean the same thing?
Yes. Yes.
It's equal to the exact same thing, yes?
Yep.
So one of the g at x's is equal to this, and one of them is equal to this. Agree? Do we agree that they're equal to each other? So if they're equal to each other, we can do this. And then divide each side by negative 10 and reduce it. So it's going to be negative 3 over 2. Done. Cool? Wait.
Where did G go from? I said negative 1.5. Is that okay?
I like it.
Oh, I did that too.
So I have this and I have this. It's the exact same function. It's like you have one of the functions you had over here is negative 10x. You knew it was negative 10x, and then you had somebody over here who actually figured out g at x and said, well, I know that g at x is equal to 15. So you can say that the two are equal to each other. So that and that are equal. So then I solve my variable. So it's like saying y equals negative 10x and y equals 15. Y is equal to two different things, so you can set the two different things equal to each other because the y's are equal. Right? All right, moving on. Anything else on page 51? Yeah. 5. All right, number 5, we have a graph. I'll draw this pretty bad rendition of it, but let's try this. So number 5, we have something that kind of looks like that. I don't know, I might be off a little bit. So find the value of x so that we want to know what the x value would be so that the function at x is equal to 7. Okay, what does f at x mean the same thing as?
Ooh.
What?
Y.
It means the same thing as y. Okay, so I have the x-axis, I have the y-axis. Agree? Does that make sense? So now you're saying, hey, so this is the same thing as f at x, you just told me. So I want to know 1, 2, 3, 4, 5, 6, 7. So what does this goes over to here, which comes down to here. So if you look on your graph, if I use my arrows, if I'm coming down to here, I just go straight across, find my line, and then go straight down. Mine looks like 3. So what is x equal to? X equals 3. So that's actually called like an interpolation. You're going from one of the axes and you're going to get to the other one. What else we got? Anything on 52 as well? Yeah, go ahead.
7, A, B, C, D.
Okay. All right, I'm going to draw this the best I can. Looks like it crosses at 3 and 6. Is it 6?
Yeah, 6.
Okay. So we have this type of situation, right? Agree? All right, so A says what values of x is y greater than 4? Okay, so this is my y. So that's your 4. So what values of x allow to our y value up there to be, so it's like this part of the graph we're talking about. So again, if you look on your graph, it looks like if I go up to -4, then I go to the left, it goes from, well, this graph is eventually going to get to -infinity, but from -infinity up until -2, the graph is above 4 in the y direction. Does that make sense? It's kind of a different idea to think about. Okay, let's move a little bit further forward. Letter B, what values of x is y less than or equal to 0? Okay, so here's the y line, right? Or this is the x line. So y equals 0 is here, y equals 1, y equals 2, y equals -1, -2, -3. So where does this line, where does our red line appear to be below the blue axis? Where does it start going below the axis? What point is this? Algebra? 6. So, and then it's equal to it, so I guess I could make a square bracket here. So starting at 6, and I'm going to go forever this way. What's forever this way? Infinity. And again, I'm talking about, this is what the x direction's doing, and then the y direction is going to result in values that are less than or equal to 0. Okay? Again, it's another kind of big idea, and we're talking about this portion of the graph, but we're describing this portion of the graph in the context of the x-axis, which is the horizontal axes. Okay, so that's A and B. It's different in axes. Letter C, what values for x is y in between? So between 1 and 4. So what values on my x am I between here and here? Okay, so here, what point was this? When I came back, look on your graph, what point does this come down to? -2. I guess I can go square bracket. And then, what's the other one? 4. Bless you. I guess, hang on, I'm off for a sec. I just reread that wrong. Okay. I gotta sit down to do this. All right, hang on, I can get this. What's a good color we're all gonna see? How about this neon green looking thing? Okay, so y, this is 1, this is 4. Okay? Did I write that down right? Y is between 1 and 4. So what values of x are between 1 and 4? Well, it starts here, and this is coming down here. So then what we're going to do is we'll do this in orange. Where does that orange seem to span our equation? Oh, I guess I got to take it up. So 1, 4, I didn't go high enough. 1, 4. So this also comes up this way. And then I also have the orange this way. So what is the distance of that orange way up there in the x direction? So where is that here and here? And then where does this go to there? So -2. I guess I could go square bracket because these are equal. So -2, and it goes all the way up to 0, and then it starts over again. So I don't know, it doesn't really, even though that, you know, these are the endpoints, I think I can just continue and just say that it goes to 1, 2, 3, and 4 at think that's right. So where is our y value exist between 1 and 4? So we have to look at the x. And then what is the domain of this whole thing? Does this graph go forever left and forever right? So our domain will go from negative to positive infinity. Totally different type of thought process on these. Okay, questions on 52. Questions on 52. Yeah, 8. Number 8. Number 8. Okay. All right, so if you're looking at your graph, if I wanted to go f at 3, so I'm not going to draw the whole graph out. So 1, 2, 3. If I do this point right here, what y value does it go with? Oh, x. Okay, so what does that go to on the number line up to the left? So this is 3. Our graph comes down to right here, and this is -1. So what is this point right here?
Oh, -1.
-1. So f at 3 yields me -1 as a point. And then f at 0, I gotta look back at our graph. F at 0, so right here, the graph is back down here again. So what does f at 0 give us? It's right here again. -1. And then f at 6, 6 is way out here, so 4, 5, 6, and then that's down there again, so it's -1. So all those are all -1. What does the domain appear to be? Is it going forever left and forever right, even though it has some wiggle in the middle? So the domain of our graph has to go from negative to positive infinity. What is the range of our graph? So what is my lowest down y value I have on this graph? -1. What is my highest y value? 1. Is it 1 or 2?
It's 2.
Look on the y on this one, the vertical. Make sense? I see you were seeing the 2. I got where you're going. Okay. Intervals for where it's increasing. So that's up to 1. So right there, it's increasing. And I'm not going to draw the whole graph. And then 4, increasing there as well. So those are the 2 spots that the graph is totally increasing. Increasing here and increasing here. So this graph is increasing. Tell me in the x direction how it's increasing. What's the furthest left number in the x direction to say where it starts increasing? What is this number here? 0. Good. So from 0 up to right here, where is it increasing? What number is that? Count. 2, isn't it? Did I do that right? So it's increasing from 1 to 2. Now it's increasing from here to here. So where's this increasing? 3 to 4. Good. So you're talking about what's going on in the x direction to allow it to be increasing. If it's increasing, it means the slope would be positive. So those are the intervals for that. And then letter E says, hey, where is this whole thing positive? So what did positive mean yesterday when we talked about it? It's above what? Which axis? The x-axis. Okay? So this is my x-axis. So I can't see the whole graph. I have some of my paper. But the rest of the graph, I guess, would look kind of like that to there. That to there. That went that way. And that went that way. Okay. So right here, it's positive. Right here, it's positive. So let me just kind of shade in, color in that region a little bit so we get a little bit better look at it. So this region under here, That's positive because it's above the x-axis, as well as this. Again, my graph isn't perfect, so you might have to look on your paper to get a little bit better. So those blue highlighted parts. So it looks like it's positive from about 1.5 on the x direction up to 2.5. You most complex thing that we're doing all year and you're leaving? Just trying to point out a few things, but I might not know what I'm doing. All right, where's this next region? Where is this starting to take place? 3.5. Going all the way up to what? There you go. So that's where we're talking, using the x-axis to describe to us where our graph's positive. So if I plug in any values from 1.5 to 2.5, I plug that into whatever my equation is. I have no idea what the equation. I will come out with a positive number. Okay, and if I plug in any number between 3.5 and 4.5, I will again come out with a positive number. Anything else I plug in, the number comes out to be negative. Okay, that means it's below the x-axis. Different concept? Yeah. That's it's a good pre-calculus concept right there. And I think a lot of you see it. Some of you might not. Is there anything about that problem that I need to explain a little bit differently? Seem good? Cool. What other questions do we have on page 51, 52? What else we got? Have it out. What else do we got? Different concept, right? Not impossible, just a different way of thinking. Anyone want me to go over number 9? Same idea. Or do you feel comfortable with it? Is that a yes? Go over it? Cool. Happy to do it. Let's change colors. Number 9. All right, let me see if I can draw something that has some Methodist madness in it. 1, 2, 3. 1, 2. That's 0.5, 4. This graph appears that it stops and starts, right? Appears it's doing this. I think I have that about right. All right. F at -3. So what is this value right here? Because that's -3.
0.
Good. F at 0. So what is this point? Because this is 0. 2. Making sense? And then F at 5. There you go. Perfect. You're getting it. Domain. Now let me ask you this. Are there arrows on both ends of my thing?
No.
So it starts and stops?
Yeah.
So where does it begin? Negative. Back here?
5.
-5. And it's a solid dot, so I'm going to go square bracket. So -5. And where does it end? +5. And it's a solid dot, so negative to +5. You okay with that? The range. Okay, so we're reading from the bottom to the top. So what does my lowest y value appear to be? Remember, y goes this way. Yeah.
Wait, for the domain, so it's -5 and 5 because it's
So it starts at -1, -2, -3, -4, -5. So
and it ends at 5.
and it ends at +5. And then the range starts here. What's this lowest point? -1, and I'm going all the way up to -4. Cool. All right, so I'm going from -1 to +4. And there's square brackets because they're solid dots. That means I include those points. Interval where this is increasing. All right? We're increasing here, and we're increasing here. There we go. So, where is this from here to here? From here to here, it's increasing. So what's this x value here? X value. -1, 2, 3, 4, 5. That's -5 all the way to this x value. 0. So it's increasing from -5 all the way to 1. And I'd probably do rounded brackets there. And I gotta be honest, on this stuff, I might not be looking at your square versus rounded brackets as carefully. I think this is a really big concept. I think you can get this. And if I'm nailing you on little nitty-gritty versus square versus rounded, I don't think that's where we need to go. Now, the next pink line, where in the x direction does that appear to be starting? What point's this? 1, 2. So it starts at 3 and it goes to 5. Okay? And then where is the graph positive? Positive means it's above what?
0.
Why is it -3?
Because it's under the line.
Oh, I agree with you. This is -1, but count in the x direction. 1, 2, 3. This is +3. That the graph does exist down here at +3. And then so from here over to here in the x direction, it has a positive slope. That's what it means. That's a great question. And I know that this stuff twists around your head. It's okay, it makes you normal that it twists around your head, okay? All right, so when it's positive, it means it's above what? The x-axis. So let me just kind of, I'm going to color this region right here. I know I'm not going to be the perfect artist, and I apologize. Is that all right? And then here as well. Those are my two spots on this graph that we have a positive answer, meaning it's above the x-axis. So it's positive. Okay, now describe to me when in the x direction under the triangle, it goes from what to what on the x-axis? Close. Careful. Which 3 is it?
-3.
It's -3. All the way up to what point on the x-axis?
0.
2. So between here and here, I plug any values in, whatever this function is. If I knew what the equation was, if I plugged any values in between these two, I get a positive answer. If I plug a value in over here, my answer is negative. If I plug a number in between these two, it's negative. And then that other one looks like it's about 3.5. And that goes all the way to 5. So from 3.5, which is about right here, if I keep going this way, my graph still exists above the line. Okay?
Hey, wouldn't it be -1?
You help me out. Where are you at?
It's calling that positive. If the egg, like if the egg starts at -1, and
Alright.
it's going up positive.
Okay, so
then when
are you asking for positive?
yes.
Okay, so we're talking about where does our line exist above the x-axis, but we're going to use the x-axis to tell us where. So from -3 to +2, in between these, my graph exists above the x-axis, and then from 1, 2, 3, 3.5 to 5, it's also above the x-axis. That's what it
Yeah.
means to be positive.
I'm just saying, why wouldn't it be at -1? And then it's like above the x.
Because negative 1's right here. In the x direction, it's -1.
On the y.
Okay, so I'm using x to describe it. So this is my describing line. This line's describing what other things are doing. Okay? Good questions. All right, so will you all do me this favor? So being it's 2 pages again, will you make sure your name is on the top and just pass page 51 forward? Or if you're handing anything else in, keep 52 for right now. Is that all right?
I wanted to see if I could fit your hand.
I was really good.
Just start.
Nope, stand.
You're all sitting behind. Go.
All right. These shouldn't take too long. Please stop me as soon as something gets goofy in the head. It shouldn't be goofy yet. I'm stuck. My brain's full. Oh, sorry. Great questions from the homework, by the way, everybody. Okay, graphing, linear functions. Linear functions, is it linear? I don't know what that means. Let's find out. So this is nonlinear. Why is that? It's not a straight line, right? Make sense? What about this? What do you think? Is that linear or not?
Yeah.
It is. The reason why letter B is linear, even though we have a bunch of x's and y's, you don't have x raised to an exponent. You don't have x in a denominator. You don't have y as an exponent or a denominator or under a square root sign, so that's totally linear. And then this, linear or not?
Linear.
Okay, so common difference, I would have to add 6 there, add 18 there, and add way more than 18 there. If it's linear, your y values should have a common difference. So this is nonlinear because my y values don't grow by a common value. Look at my x's. It goes from 0 to 2, 2 to 4, 4 to 6. Okay, those are all sequential somehow. So first thinking, let's see. Linear, can't be circles, can't be this, can't be this. Okay? You can't have the square root of x, you can't have 1 over x, you can't have x to some number, x to the n power. Okay? But on linear this way, I could have ax plus by is equal to c, or a, b, and c are any numbers. Are numbers. You could have y equals mx plus b. We'll start using that. And then we could also have x equals some number. Y equals a number. And those are special straight lines. X equals a number is a vertical line. Y equals a number is a horizontal line. Can I move on?
1 sec.
1 sec. You got it. What time are we at here? 48, right?
48.
Okay. We ready? All good?
What's y equal?
Y equals a number as well.
Oh, okay.
So you have like y equals 7 is a horizontal line going through 7. X equals -6 is a vertical line going through -6.
Okay.
Cool? Good to move on? All right. All right, what makes something linear? So so that's linear, that's linear, that's linear, and even that's linear. So you have a slope that's positive, a slope that's negative, a slope that's 0, and then you have a slope that's undefined. Okay? So that's a 0 with a slash through the top of it. Nonlinear things, well, we talked about it. It could be, that's not a, it doesn't look like a straight line. That's not a straight line. That's not a straight line. That wouldn't work. Okay, so those are nonlinear things. So again, you have to make sure your x, if you had x squared, or if you had y, the square root of y, or you had 1 over x, all of those things don't make linear. Or even if you had sine of x, cosine of x, tangent of x, that takes care of sin, cos, tan on your calculators. Linear stuff, you have x, you might have a number in front of x, you might have 3x, you might have 5y, those all work. Okay, as long as your x's and y's aren't exponents, denominators, under a square root sign, or have sin, cos, tan, or log or natural log, so log of x, or natural log of x, or 5 to the x power, all those things are nonlinear. Okay, so there's all kinds of there's more nonlinear things than there are linear. How many linear things are there? Infinite. So how can you have more than infinite? You just can. That doesn't even make any sense. We can't fathom infinite, right? Unfortunately, no one's mind will, and that's okay. Then you get the one who's, what about Googleplex? It's not infinite. Yeah, it is. You know what it is? You know what a Googleplex is? You know where it came from? I think this is the dumbest thing I've ever heard in my life. I mean, honestly, but this is actually what a Googleplex was labeled to be. You know what a cash register is? You know how the cash register has a tape on it, like you'd print on paper? So if you go 1, and then on an empty roll, you start the empty roll, or you start a full roll, you go 1, 0, 0, 0, keep hitting 0 until it's the very end. They call that a Googleplex. Is it infinite? It's a huge number, but it's not infinite. But some 4-year-old kid said, that's called a Googleplex. And they're like, yeah, he's a genius. It's like, no, he's a moron. He's a lazy kid going 0, 0, 0, 0, 0. So, but apparently that's some mathematically accepted idea. But that number 1 with zeros on a tape, every line on a tape, would be like filling up a whole sheet of paper with 1 with a whole bunch of zeros and keep going. And nope. 1 and 0. No. No. Yes, on a piece of paper, we can't get to infinity on a piece of paper because we only have limited paper, even though it's a lot of paper.
Wait, how do you get?
So if you ever want to have fun, you ever want to mess with somebody, like you're over at your buddy's house, type in give me pi to 5 billion places, copy and paste it, and then hit print and leave. They'll come home 2 weeks later and the printer's still like, why are we out of paper? Hon, who typed pi in? Okay, discrete, continuous, independent, dependent. So discrete, so just a few things with discrete. Something like your height would be discrete. Is everyone 5'6"? Or could someone be 5'6" and a little bit more? Like when you're growing, you're not going, got to the next inch, got to the next inch, got to the next inch. You have like in between, right? Yeah. Okay? So discrete versus continuous. So the kid who grew here went from 1 foot tall to 2 foot tall to 3 foot tall to etc. The kid here was like, 1 foot, 1.0001, 1.002, kind of growing. So continuous kind of just flows all the way through. Discrete would be like if you were just counting by whole numbers. Independent versus variable versus dependent. These are your x values versus your y values. Oh crap, really? Okay. How far did I need to go? And that's. Okay. Oh wow, that's close. All right. So hey, do me this favor for next time, because I did run out of time. So, will you remind me of this too tomorrow? Because I'm gonna forget. Because you know me, I'm not bright. I'm as bright as a keyhole and as sharp as a marble. So 51, 52. So I would like you to get a good try on page 53, 54. A good try. A try, does that mean it's totally done? No, it means you come in with questions, right?
Yes.
Get out of here, everyone. Have a great day. Take care of one another.
How do people figure out the numbers to pop?